So guys, welcome to our channel once again. In today's video, we have here these 5 questions to answer on the topic electromagnetic field. So guys, this video will be about inductors or induction. So in short, stay till the end of this video. Let's go ahead and start with the first question here. It says, a coil of inductance 0.12H and resistance 4 ohms is connected across a 240 volts 50 Hz supply. Calculate the current through it. Take pi to be 3.14. Alright, so we have options here. So we are just going to start by calculating the reactance of this. Then when we get the reactance, from there we can now substitute and get the current. So let's use the formula that reactance XL is equal to 2 pi FL, where pi is 3.14, then F is the frequency, which is 50 Hz, and then L is the inductance, which is 0.12. So guys, let's go ahead and plug this in and then calculate for reactance XL. That will be 37.68. So guys, let's also recall that the reactance XL is equal to voltage over current. So in that case, if we make current the subject of the equation here, we're going to have that current is equal to the voltage over the reactance. So the voltage 240 volts as stated in this equation, we are going to divide it by the reactance, that's 37.68. so guys, when we divide this, we are going to have 6.3 amps, and that's option D here. So guys, that's the answer to this question. Let's go ahead and consider the next question, guys. So that's question number 2 here. We have a diagram here, and we have to answer this question from this diagram. So it says here, calculate the inductance L of the coil in the circuit diagram shown above. So guys, we are looking for the inductance of this circuit diagram. So guys, from this we can state that the reactance XL is equal to 2 pi FL. So already we know this equation. So first of all, we don't have the reactance from here, and we don't also have the inductance L from here. So first of all, we are going to look for the reactance, which is XL here. So reactance, as you all know, is voltage over the current, which is 240 volts here over 2 amps. So when we do that, we're going to have 120 for the reactance. So the reactance is 120. So in that case, let's have that reactance is equal to 2 pi FL. So if we make L, which is the inductance, the subject of this equation, we are going to have XL, that's the reactance, over 2 pi F. So the reactance already we have to be 120, then over 2 times 3.14 times the frequency here, which is 100 over pi. So in that case, we're just going to plug this in and calculate. So when we calculate this, we're going to have 0.6 as our inductance, and that's option C here. So let's go ahead and consider the next question, guys. So that's question number 3 here. It says, a direct current of 5 amps flows through a 0.2H inductor. Calculate the energy stored in the inductor. So guys, this is just very simple. We are going to use the equation E is equal to half Li squared. So in that case, we are going to have that E is equal to the inductor, which is 0.2 times I squared, which is 5 arms squared, that's 25, and then this will be all over 2. So guys, if you go ahead and calculate this, we're going to have 2.5 joules, and that's option D here. So that's the answer to this question. Let's go ahead and consider the next question, guys. So that's question number 4 here. It says an inductor of inductance 10H carries a current of 0.2 amps. Calculate the energy stored in the inductor. So guys, here as well we are going to have that E is equal to half Li squared. So the inductor is 10 already, then the I squared, that's 0.2 amps squared. So all this over 2. So this will be 10 times 0.04 over 2, and that will give us 0.4 over 2, and that's 0.2. So option C here is the answer to this question, guys. 0.2 joules. So let's go ahead and calculate the next question. Let's go ahead and check out the next question, guys. So that's question number 5 and the last here. It says the energy E stored in an inductor of inductance L when current I passes through it is given by the equation A. E is equal to half Li squared. B. E is equal to half Li. C. E is equal to half L squared I. D. E is equal to Li squared. So guys, the answer to this question is option A here. That's E is equal to half Li squared. And that's it for this question, guys. So this will end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community. You can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.